All right, hi guys. Today we're going to talk about or complete lesson 3, ionic and metallic bonds. So please get your notebook out and record all notes in your notes. So previously we were working with covalent bonds. Now we're going to start working with ionic and metallic bonds. So remember an ion we talked about back in the beginning, you might not remember, but these are atoms that are no longer neutral. So they don't have equal number of protons and neutrals. They have gained or lost an electron. So a positive ion is an ion that loses an electron. Sorry, not end an electron. That should be N. And a negative ion is an atom that gains an electron. So losing valence electrons. So metal atoms tend to become more stable when they lose electrons, and they lose electrons to make full energy levels, which make it more stable. On the opposite end of the periodic table, nonmetals will gain electrons to become more stable. So they gain electrons to get 8, a more stable arrangement. And our most famous example of this is sodium chloride or table salt. So sodium is the metal. It will lose this electron. So basically it gives the electron to chlorine. It becomes a positive ion. Chlorine is the nonmetal, it becomes a negative ion. And this positive attracts the negative. So that's how they bond, by the charges. So in ionic bonds, metals, remember, typically lose electrons. Nonmetals typically gain electrons. So your metal atom becomes positive, your nonmetal becomes negative, and that positive is attracted to the negative, creating our ionic bond. So that's the attraction between a positively and a negatively charged ions in an ionic compound. So ionic compounds tend to be between nonmetals and metals. Please make sure you copy this chart. They transfer electrons or give from the metal to the nonmetal and create positive and negative charge. They are usually named with Greek prefixes, solid at room temperature, have high melting and boiling points, and a high attraction between particles. So they're very strong. Covalent bonds, which we talked about previously, are between a nonmetal and nonmetal. They share electrons, they don't transfer them. They have no charge. They're named with Roman numerals, and they are usually solid liquids or gases at room temperature. They have low melting and boiling points and weak attraction between molecules. The final type of bond is a metallic bond. A metallic bond is a bond that forms when metal atoms share their pooled valence electrons. Metal atoms form compounds by combining and sharing all this electron. So it's like a sea of electrons. They're not bonded to one atom, but they are shared between all the positive nuclei. Metallic compounds are good conductors of electricity and thermal energy. Their valence electrons move easily from ion to ion, which makes them ideal to conduct electricity. They can be hammered into sheets or drawn into wire, so they're ductile, and they are usually very shiny, so the valence electrons are at the surface, interact with light. So if we compare the three, covalent bonds, remember they share, ionic transfer, and metallic also share. Ionic is between a metal and a nonmetal. Covalent is between two nonmetals, and metallic is between two metals. So there are 3 types of bonds. Remember, these are not good conductors. These are good conductors. These usually only conduct when dissolved in water. That's the end of our notes. I'm also going to put a video on there for you today. So please watch the video and then come back and mark as done.